Hey guys. This guy. Sorry guys, I've used to working away in silence. It's hard to narrate and do your thing at the same time, but I'll try to narrate more. Clinton is pushing me in the right direction, so make sure I say something. It's just capturing, it's an older phone. I think it's my iPhone 10. It's sitting up, I've got it mounted up on top of a 10-foot pallet rack. It's capturing basically the entire view of the two CNC machines here. Over here on the right, I have got the Shabuko 5 4x4 with the Warthog controller that I'm not very happy with. Over here on the left, I have got the Masso Elite. This is actually the very first Elite machine. It's got several prototype pieces on it, so it's not exactly production, but it is as close to production as we can get it. Let's see. Oh, and the pink Post-its. So over here, and there's another one over there. That is basically where the 12-foot pallet racks will extend out. And I'm trying to design this CNC area so that we've got a 12-foot pallet rack here, 12 foot wide by 12 foot tall. And then over here, another 12 foot wide by 12 foot tall. Over here is probably going to be like a bay thing where you can get in there and we can roll machines in. I can kind of squish these two machines together a little closer. Over here, I'm actually contemplating adding some additional shelving because I've got so many of the little CNC machines, the 2x2s. It would be nice to have all of those up and actually functional so I could actually sit down and answer questions and that sort of thing. So I'm thinking about putting a shelf down low, a shelf about workbench height, and then another shelf just above that. Not as high as the ones that I've got in our work areas, but that way I can actually line up. I've got 12 foot wide by almost 44 inches, almost 4 feet back to the wall, which is plenty of space for all these tiny little CNC machines. So, I don't know much about streaming, which is surprising as a computer person, but I do have several GoPros, and I use those on the machines themselves whenever they're carving, just to capture raw footage. I haven't figured out if it's even possible to YouTube stream from a GoPro. That would be really nice though. I typed fast enough for both of us, Clinton, not to worry. Now, let's see. All right, let's see. Testing, 1, 2, 3, testing, 1, 2, testing, 1, 2. I've got to get, where did my other, let's see, got one on there, one on there. I need an IoT power strip. All right, let's see. I'm going to pull the IoT power strip off from the Shapoko 5 so I can install it onto the Infinity. Got my 6-foot cable there. So if you don't know, this is the IoT power strip. I buy these from data loggers in bulk to try and save everybody some shipping because they charge like $15 for shipping one little piece. And so I have a whole bunch of them shipped here so that they can actually be included in your orders if that's what you choose to do. I have got the simple 2-conductor wire. I sell it by the foot on the website, as well as the little IoT plug that plugs into the side of the VFD. This little guy, basically this entire setup, will let you control your shop vac. Okay, something popped up in my hood. Apparently Discover wants to tell me something. Okay, so I'm going to have the power strip plugged into the wall right here. I've got the power strip sitting here, plugged over there. And I'm going to pull my shop vac, which is sitting down here. Pull the cord out, get it underneath, plug here. So that it could just plug right into the normally off setting. That's out of the way. I'll run this over there to my, so I've got a VFD already plugged in underneath the machine. I'm just going to run this right over there and plug it in. Right into the side. My wire management is horrible right now. But okay, so what I've got is I've got so this is basically the same setup that I brought to Workbench Con, other than the additional parts up here on top so I can demonstrate them during the video. But under there is the same VFD. It's mounted vertically like this. On one side we've got the power and the spindle cable. On the other side we've got the manual override switch, the IoT trigger, and the PWM or Modbus controls. The Elite plugs in with a Modbus. There's a simple little cable right here that plugs into the little GX12 aircraft connector underneath. Now, the way I've got it set up is the shop vac is turned on, but being that the IoT power strip will control that much power, it's not turned on. It won't actually kick on until we actually run it. So I've got it on manual override. That way I can hit the run button here on the side. This is another a screen mount for the power, or for the VFD. It's sitting at 0 RPMs, and if we increase that to 5,500 RPMs, the shop vac kicks on. And they go below that, shop vac kicks off. All the while, the spindle is running under there. And of course we stop, and it stops it altogether. So I've got the V10 mounted to the to my 80mm air-cooled spindle here. This is the 1.5 kilowatt. I've got the 80mm spindle mount base with the 1.5 inch attachment. This is my Fine Turbo 1 shop vac. I've also got a second control arm with the 90-degree base And in this case, I believe it's the 3XL arm, so that it reaches it up vertically, and then another 1.5-inch attachment right there, so that it grabs onto the back hose. This comes down right into the boot and snaps into the base. That way there's plenty of slack, so that when this spindle goes down, the hose goes with it, and it doesn't yank or pull too much under on the hose itself. So let's see. Any possibilities of making some brackets to make dust boot compatible with open style build CNC? Yes. So I do have a work bee, the 2x2, the tiny one, that will be mounted over here, and I do plan to design some brackets for it. I've already done some initial research into it, and it does work. I can get it to work, so I just need to sit down and actually run through the design, and everything I've been doing in the warehouse kind of leads towards that. Everything from cleaning up the bins and having a place where I can put the finished product, so that whenever orders come in, I can just quickly grab it, put it into a box, ship it out quick and fast. That's my main goal. I really want to get these products out like the same day or the next day, or maybe 2 days later max, quickly. But having all of that ready and available has been great. I can finally get back to designing, and I've already come up with several new designs, including the keypad mounts, kind of expanding on that idea, which is what I'm hoping to do with other products. Clamping. There is a new product that I've just finished producing that will be very interesting. This one is it's sort of like a fence, but it's not. In this case, it's just it's one of our M5 T-track nuts, the ones that are compatible with every single T-track out there. This little guy here, and then that mounts right onto a little block, right? And this little block will slide right into, there it is, slides right into, and you can adjust and clamp this down as a stop block for your beds. This is functions on both the Onefinity, the QCW tables, onto the Shipoko table, their hybrid table design, as well as basically every other design out there. It fits. So I've got a set of 4 of these. These are coming to the website soon. Let's see. I do actually so I've got a bunch of my experiments still at my house. And one of those experiments, let me grab it, is if I don't own the CNC machine, I own the controller for it. So here is the black box. The black box controller from Open Builds. It is fully compatible with, our spindle kit is fully compatible with this device. There's even a spot, where is it, if I can find it, that you can set it up with a relay and have it, relay. Leave it relay, and then there's a PWM somewhere. I'll have to find it later. But that will hopefully plug in and trigger the spindle. So there's, on the spindle kit itself, let me grab another wire. So, the most generic method of wiring up our spindle to any controller is using our generic Ferrell's control cable. This plugs right into the side of the VFD, just like any of our control cables. But on this side, we actually split out all of the wires that are necessary. The red and black wires are for the PWM signal, the voltage and the ground. This is how you control the RPMs. Most CNC machines have the ability to control a PWM spindle. That's how you do it. The other controls are all special and unique. So, well, unique in the fact that if you connect the white wire is the digital common, and if you simply touch the yellow wire with the white wire, it triggers the forward function. That's equivalent to just hitting the run button on the keypad. If you disconnect it, it's basically stopping the forward function. So that's where you can plug those two into a relay on a controller. At a bare minimum, you need the PWM signal, which is basically the bare minimum of what the Shipokos will provide, unfortunately. They've stripped down many of the generic controls that are really nice and only focus on their tiny little controlled environment. Somehow Alexa thinks I'm talking to her. Siri thinks I'm talking to her. But at a bare minimum. So they like to control everything. They're sort of like a walled garden of Apple. They're trying to become an Apple of CNC machines where no one is allowed to play unless they authorize it. And they don't authorize anybody to play, which is why they're fighting me all the time on the wiring up a spindle. Their newest Warthog controller, their spindle plug, sucks. They've got some sort of heartbeat or something. I have random information on what it's actually doing. But if you tell your spindle to go 12,000 RPMs, it may go 10, it may go 3, it may go 50, or not 50, 15. It doesn't work right. So trying to get into that programming pin, that ICSP plug, seems to have worked, but something has changed on mine. I'm having to troubleshoot it. But even they support the PWM on the older machines. Now you can hook up a switch to these two, to the yellow and white wire, and just have a little flip switch if you want a flip switch, or use the simple Cat5 cable to extend the VFD's keypad to a more convenient area, like up there near the control area, for example. But touching those two wires triggers the forward function. Touching the white wire and the green wire, by default programming, is the E-stop. Now you can reprogram the VFD with one little setting that'll change it from an E-stop to, let's say, the reverse. You want the spindle to go in reverse. If you got a metalworking spindle or something like that, or if you want to have a different type of input, there's a lot of inputs available in the manual, which is available on our KB. Lastly is the orange wire. This is the 6th wire. This is the one, right? This is a GX12, GX12 6-pin connector. And the middle wire is a 10-volt signal. This is where you can send it a 10 volts of power. Some machines require it, like the CNC for Newbies, their branded controller, the C4N controller. That's where you'd need that 10 volt power from the VFD to come into the controller, so that the controller can determine how much of that is passed over the PWM lines. But this one controller basically will let you plug into nearly every single CNC machine out there, which is really nice. All right, let me catch up on text. I can't read this fast. I can type like crazy. I can't read fast. Let's see. Alright, let's see. What are... Oh, yeah, vector controls. So, if you guys want to know, our VFD can do vector control. It is not that fancy of a feature. Vector control, it's basically the VFD compensates for the amount of power required for the cut. If you think about Onefinity Elites, their closed loop steppers, that's where that applies. It does not apply to a spindle motor, unfortunately. The technology out there, if your gantry is experiencing some pushback, in order to keep the number of steps, it uses a closed loop vector control. That's exactly what it means. Our VFD and many other VFDs out there will run on sensorless vector control, specifically. And it's even in our manual, so it's not a hidden feature. It's just not a selling point, unfortunately. I've already talked with the manufacturers. I have a great relationship with them. Thanks to you guys for buying our spindle kits. It gives me the power to negotiate for all of us. That's why I listen to you guys all the time. Every piece of input, the good and the bad, I absorb it all. I write it down, I take notes, I discuss it with our team so that we can provide the best product. And through our collective bargaining power, I'm able to negotiate saying, hey, if I'm selling 100 spindle kits a month, for example, I can tell the manufacturers, hey, look, you're going to lose our business. 100 kits a month. You're going to lose our business if you don't provide us the features that we want. So, for example, well, I'll touch on that in a minute. So, the vector control, the sensorless vector control, I've already negotiated with the manufacturers. They've specifically told me that no motors out there, no spindle cutting motors out there have the sensors feedback to provide that additional information to close the loop. That's not what that was designed for. The closed loop, the vector control, is designed for stepper motors. So that's why these things are really cool. This extra functionality, all these pins and wires that go back to the controller basically tell the controller if something is pushing back, in order to keep the number of steps, push harder, right? Unfortunately, that's not something that can come on a spindle motor, not at our price range, not at the range that would be actually reasonable for anybody to actually purchase. So it's an industrial feature maybe, but it definitely is not on hobby or consumer level grade equipment yet. We'll see what the future holds. Again, I'm continuously asking the manufacturer to provide this type of motor, but at the moment, we've got sensorless vector control. Now, bargaining power. You guys have helped us out. I'm representing you guys, all of you. Everybody who's interested in a spindle kit, wanting to buy it, there's a reason why. One, our kits are expensive because that provides, one, an ability to do all that we're doing here, which better helps the community, which is my primary goal. I really want to help you guys out. Provide you the features, the products, and the designs, and to help grow the community. I encourage makers. I love makers building products, building their own products, building our products. I encourage you to design something. Get out there and just do it. You'd be surprised how many people are interested in it and interested in some design you've come up with. If you solve the problem, guess what? Probably at least 10, 50, 100 other people have got that same problem, which is basically how I started out. So, all this bargaining power basically allows me to push the manufacturers, and they've taken me seriously this time. This year, thanks to all of the sales from the previous years, from the previous year and a half or so, I've been able to pressure our manufacturer into designing, they're designing a brand new motor just for us. Now, they'll probably sell it to everybody else, whoever wants to buy it, of course. But they're designing us a motor. I've asked for two things. One, I want an ATC motor that runs on 1.5 110 and 2.2 220. So those are our two main power choices. So both both motors are going to be water cooled. They're going to be ER20 tool holders, and all of the controls, the air controls, the power, the sensors, all that stuff is up on top of the motor, so it's nice and convenient for us to install into our hobby CNC machines. They are currently talking with their manufacturer, their suppliers, to provide all the parts needed to make these motors. So these two motors are being designed just for us. And then of course they'll sell them to anybody who wants to buy them. But the fact that you guys have provided us the ability to pressure them to say, hey, we have enough volume, let's get some nicer motors out here. So a huge benefit of getting them to make these motors is it provides everybody, all of our customers, an upgrade path, right? So there's three main components to an ATC motor. You've got the VFD and the electronics. There it is. This is a really nice setup, super simple, easily upgradable with additional features, and there's even more features coming. Stay tuned. Probably Black Friday is when I've got all the supplies and everything in just the right timing. So Black Friday this year, good things coming for electronics. The second component is the motors. The motors is what I just discussed regarding the two options, two large options. They're both going to be 80 millimeter. They're both going to be water cooled. Again, ER20 collets, tool holders, and all that stuff. So you've got the electronics, you've got the motor, then you've got the pneumatics. The pneumatics requires a good, basically 90 psi air supply. So if you haven't already bought one, you can anticipate the ATC need by getting yourself a good air compressor. I've got a small little canister style California Air, super quiet. I've got it plugged up to my HDM back at the house, back in my garage, and it provides a really good air supply. I've got it going through a mister right now. That's the only thing I'm using it for. Excuse me. I've got a really nice California Air cabinet style air compressor over here hooked up to the laser. That provides really quiet, people can actually work. I mean, this is a giant echo chamber basically. We're actually looking into adding some noise foam up on the walls to try to quiet the echoes. We've already added foam around the 3D printers, and it's been helping. So now we just need to kind of extend that a little further. But, so an ATC is coming. Our spindle, our VFDs have sensorless vector control. They all have it. They've had it all this time. It's nothing new. There's no setting in there that you have to change. I think it's P0002. I think, if I remember right, is the thing that turns on the vector control, and it's on by default. So we have vector control. Let me catch up on chat. Let's see. Yep. So something I adjusted over here just a moment ago. If your controller, remember, controllers come in different sizes, different shapes, and that sort of thing. The Mega V, my Mega V, the small one, it came with an Arduino little control that basically runs the Gerbil software, GRBL software, and it allows you to plug in all basically the motors and the sensors and all that stuff, and the Gerbil knows how to control that, right? So especially those Arduino controllers, sometimes they have a very poor volt signal coming off from it, and you may need to adjust some settings. So in this case, offering the Warthog controller, the brand new one, still kind of sucks, but I can tell it to go 0 RPMs, and in running state, I was still getting a tiny little voltage, like a 0.1 volts of coming across the PWM line. You can fix that by going to, and I didn't want the motor turning in that state. When I tell it to go 0 RPMs, it should be going 0 RPMs. The way you fix that is if it is going like 2 or 3, 5 RPMs, and you want it to stop, you can go to P2013. And right now it's set, by default, it's set to 0.0 volts. Just change that to 0.25 volts. And then anything 0.25 volts or below is considered 0. So it will not turn the motor. It'll basically ignore any voltage below that. The same thing with the upper voltage. So the voltage, it's a range, right? You can adjust it. So the bottom range is P2013. The top of the range, the 10 volt or 5 volt in the case of Shipokos, is P2015. So the top volt is P2015, and it's set to 10 volts by default, unless you order it for your Shipoko, and then in which case I drop it down to a 5 volt signal. But obviously the open builds, the Black Box X32, it has a 0 to 10 volt PWM signal, just like the Masso controller here. There it is. All right, let's see. So, actually, better get that out of the bank. Okay, so let me see. I have got the VFD, I've got the power cable, I've got the power wire. I've got those things. Let me grab some motor. Okay, I have got collets, motor, power cable, and that is, control cable. And that is our spindle kit. Okay, I think I'm ready to record. So Dennis, yes, I have got my Onefinity Machinist over there, and I have got the 1.3 firmware, the RC1, the release candidate. Apparently they haven't gone production yet with the 1.3 version, but they've got 1.3.0 RC1. It has got our change. So what they're doing, what the firmware team is doing now to try to compensate for the mess that 2.0 turned into is they're releasing a single feature in each RC. And the release candidate 1 for 1.3.0 includes our change. The one that makes it in the tool list, I will do a video, if not today, probably Monday morning, because I probably will run out of time. I kind of have to wrap things up at noon to get back to my family, so because I gotta make up for a lot of lost family time. So, but yes, I will have the 1.3.0 RC1 instruction video published as soon as possible. I will also downgrade my controller back to a 1.0.9 and then re-record the instruction video. So right now the instruction video for the older firmware where you have to program every little setting, it's kind of dated. It's using our VFD enclosure version 1, I believe. And of course we're up to version 4 now of the enclosure with all the additional components and plugins and all that stuff on the side. So I will re-record that video. I will record a new video for the RC, for the newest firmware. And just like I'm going to record a video for here, and I'm going to record a video for here to try to give everybody a full end-to-end experience, just like I did on the Shipoko Pro video I did like 2 weeks ago. Yeah. Okay, now I need to do a video. Yeah. So if you don't know, if you're using your iPhone, you can pull up your iPhone's camera on your watch. And be able to see. Hey guys, this is Daniel with Morning CNC, and I'm here to show you how to install our spindle kit onto the Onefinity Elite. I've got the Onefinity Elite woodworker size here, but it does not matter which size you've got. It all has the Masso controller, and basically this is very simple instructions for installing our kit onto the Masso Elite, Onefinity Elite controller. Stick with me, and let's dig into it. Let's do it. One more shot. Make sure I can see it. Hey guys, this is Daniel with Morning CNC, and I'm here to install our spindle kit onto the Onefinity Elite. This is a woodworker size, but it applies to any size Onefinity Elite machine. This basically controls through the Masso controller here. We're going to show you how to plug it in, how to get it running, and even do a very simple test carve, air carve on it. So yeah, stick with me and let's dig into it. So no, my understanding is there are no major bugs in 1.3.0. I've been using it. I've done several 3D carves on my machinist without any major issues. They've cut out all of the 2.0 stuff. They've reverted back to 109. Then they branched off or not branched off. They've basically deleted all the 2.0 stuff, and they've started right back at 1.09, and then they've slowly added a couple of features, and then in the release candidates, they're releasing one feature per RC, so release candidate. So release candidate 1 is the one that has our change in it, that makes it really easy, and it should basically give you the stable changes from the 1.0.9 firmware up to the 1.30 RC1. So you should be good. Let's see. Okay, now I need. See if this actually has it. I can't really see anything. Okay, so what we've got here is our spindle kit. In your spindle kit, you'll basically have our electronics package, which is our VFD enclosure. Currently, it's version 4. It includes the plug-in power, the plug-in spindle power. This is an EMI filter, by the way, so you get it kind of isolates the power coming from the wall going into the box, so that you try to reduce as much interference as possible. On the other side, we have got our PWM line, which is what we're going to use on the Elite. We have the mod bus, which is what you'd use on the older 150s. We have our IoT power strip plug, as well as our manual override, our MOS plug. We'll talk about that more in a minute. Let's see. In your kit, we'll also provide a heavy-duty wall plug. We encourage you to use our plug because it will provide and cover the amperage that this VFD may be pulling from your circuit. It includes the matching spindle power cable. This depends on your motor. If you've got the smaller motors, it's going to have an H17 connector. If you've got one of the 80 millimeter motors, it's going to have an H20 connector on the end. And then, of course, on the VFD side, we have got our proprietary, it's WS16 aircraft connector that plugs right into the VFD. Next, we have got our control cable. Now, this is just a generic ferrules connector, but on the 150 Elite, it's basically going to come with a control cable that has two GX12 6-pin connectors on it. One side, and it doesn't matter which side it is. One side plugs into the VFD, the other side plugs into the Masso controller, the touch controller on the Elite. Let's see, of course we've got our motor here. This is the 80 millimeter 1.5 kilowatt water cool. And of course we do have some features where you can add no leak connectors. Through some research and that sort of thing, we found a company called Coolants. So if you wanted additional connectors, you can go to them and they have various connectors. We're using the QD2. So if you wanted additional connectors or something like that, you could buy them from them individually. We sell an upgrade pack, which includes two. We reached out to them and custom made or a motor, something we screw right into the top of our motors, basically. So I unscrew these, screw the quick connectors, coolants connectors onto there, and there we go. We've got a no leak plug for our water cooled spindles. On the machine, I have got the air cooled 1.5 kilowatt 80 millimeter ER20, both of these are ER20 motor on there, and that's what that's what I use on my machine. Included also in your kit is a couple of wrenches. These are really cool. I've looked everywhere for these, and it's really hard to find. These are thick 5mm hardened steel wrenches. These are really nice, very comfortable, especially with our grips here. And I think I've got another 2,000 of them on the way. They should be arriving by sea any day now. If you've got the 80mm ER20 spindles, it's going to come with a 1/2 inch, a 1/4 inch, and an 1/8 inch collet. But we also have additional collets as well as metalworking collets if you want to get a little more precision out of it. The TIR, I'm drawing a blank on the runout. That's it. The runout of our spindles, I believe, is a 0.01 or 0.001. It's on our website. This is on our website. But that's more than enough for these woodworking collets and the woodworking nut, which by default all nuts are balanced at 14,000 RPMs, which is more than enough for woodworking purposes. On our metalworking spindle or metalworking collet nuts, they are balanced at 18,000. That's why they're nice, pretty, and fancy and silver. But I actually have to pay extra to the manufacturer to get them to balance it at a much higher rate. And of course that's something that contributes to metalworking. So, but for all of us making wood or carving wood or even just basic aluminum, metal or woodworking collets and such are fine. But yeah, if you want to go that extra mile, we've got all that metalworking supplies that are slowly growing in our catalog. Let's see. So we've got all of our parts. Let's dig into the actual installation, and I will show you. Yeah, let's get on with it. So a huge advantage of our spindle kits is the manual mode switch. So it's our MOS switch here on the left side of the VFD. We put these on there because initially we found out that it was really nice that if we wanted to just jog the machine around and hit in there and just run it up to 12,000 RPMs and get that surfacing bit in order to get the last few inches of the bed carved, and just run it in manual mode, just kind of jog it around. But it turned out that this has been one of the greatest features we've added because it provides long-term support, right? So we designed a spindle kit that is generic, right? We can connect it up to multiple types of machines, multiple CNC machines. If you've got PWM control or Modbus control, we can work with you to try to get that working. What we want you to have is value right out of the box. So when you get your machine, there's instructions on our quick guide that tell you how to basically flip it to manual, hit the run button, turn your dial, validate your setting, which is basically what we've done here in-house before shipping it. And that way you can run your kit in manual mode, just like you do a palm router. Flip it on, set the RPMs, and then run your carve. You can do that with the spindle kit. Run it to manual, turn it on, set your dials, and let it carve. The reason why that is so valuable for us and for you guys is it provides the ability that if you're having trouble getting the automatic controls to function properly, we don't want you to have downtime. We care about the downtime. Seriously. We don't want, but you guys are spending, $3,000, $4,000, $5,000 on a CNC machine. And then we're asking you to spend another $800 to $1,000 on a spindle kit. It should be working. I'm serious. It should be working the instant you receive everything. And that's exactly what our manual override allows us to do. Flip it to manual, run your spindle, let it run, enjoy the benefits that a spindle provides. Everything all the way up to the automatic. When you follow our instructions on that quick start guide, it will show you how to connect everything up. If you're having trouble, reach out to us at support. We will help you out. Clinton and I are here to help you guys out and get that automatic running. What we don't like is downtime. So this manual override allows you to run your machine, get it running, gives you and us time so it's not an emergency to get automatic running. You're not dead in the water. We do not want dead in the water. We want you guys to run your CNC machines, run it, enjoy it, make some carvings, make some stuff, right? So if we're having trouble getting your automatic running, we may need to do some research. Obviously, I may need to set up, much of the time when I'm doing research, I'm scavenging the internet, finding the information so you don't have to, right? That's the value of our support. That's why we charge a premium for our product. You come to us, we help you out. If you have trouble, come to us, ask us a question. We're happy to, more than likely we've already written up a KB article, which has the information on it. If not, we are going to. That's kind of the plan, is every time we get questions, we write up a KB article. But sometimes I have to set up my machine the way you've set up your machine. Plug it in, check some cables, maybe validate some things. I might have to rebuild something or go in and grab one of our older versions of the VFD, the enclosure, version 3 or version 2, which on the KB there's tons of pictures so you can easily identify which ones which enclosure version you have. I took pictures of every single angle of the VFD, and I even took a picture of the wiring inside, so I can add that too. Since then, I've started to add a QR code and the actual version number of the enclosure. That way it's very simple to just go, oh, this is a version 4. The next one will be a version 5. It'll have a label on there with a link to the KB with all of the information about this specific enclosure. I'm trying to add upgrade information too, because again, we don't leave anybody behind. There's upgrade paths. So if you have version 1 or version 2 or version 3 of our enclosure, we have an upgrade product that includes the things that are different. And we also have a free upgrade service. All you have to do is ship us this little box here, buy the upgrade, we will build it, we will upgrade it for you and ship it back. The only thing it costs you is time. Now again, this likens back to the downtime. We don't like downtime. But if you're willing to accept that in order to get the newest features of our VFD enclosure, there you go. Send in your VFD, we'll upgrade it for you for free, ship it back to you. That simple. But we don't want to leave anybody behind. We want to drag everybody with us into the future, into our great and glorious future. So if you have suggestions or something, let us know. We are listening. Some things take a little longer to arrange. Basically, the bigger we're becoming, the higher quantity we're getting, the higher quantity we have to purchase, the longer it takes to establish things. So upgrading from version 1 to version 2 of our enclosure was really quick. I was able to buy 50 switches and get everybody working and start shipping out version 2. Version 2 to version 3 was also very quick. I was able to make some printing changes, acquire one new part to add into the feature, and then it gets you to the version 3. Version 4 took a little longer because we actually changed out our connectors on the side. Version 5, it's taking longer. I've got 3 awesome upgrades that you guys are absolutely going to love. It's going to come, I can't get into it. But it's taking a little longer because I need higher volumes. Instead of 50 or 100, I have to buy like 300 or 500 of these pieces so that, one, I can provide enough features to create an upgrade product, to go from 4 to 5, or 3 to 5, or 2 to 5. Provide all those parts necessary. But then I also have to keep up with production. So production at the higher quantity because we're getting more popular. And don't get me wrong, I am loving you guys. Thank you. You guys are making this fun, and I'm hoping it's fun for you guys, providing a path for upgrading to get to the latest products. I don't want to leave you behind. I don't want to force you to buy a whole new kit because we've added one new feature, right, that you really want. So higher quantities, and hopefully by Black Friday, I should have like hundreds. I think I'm working on getting 700 supplies in so that we have plenty of supplies for new VFDs, for existing VFDs with the upgrade path, with the free upgrade service. So yeah, stick around. You guys are making it fun. Thank you. This is my full-time job, by the way, and I really appreciate it. All right, back to my recording. Okay, let's see. So we need power. All right, let's see. that guy going. Grab the lead control cable. Alright, here we go with our elite control cable. And let's get a nice shot of that. I'm going to do a voiceover on this stuff, so it doesn't really matter if I talk during it. Let's try that again. Done. Excellent. This is going to be super simple. Now it's time to do the video on the actual controller. Alright. So I have got my connector, I moved my keypad with a special mount that's going to be on the website soon, as well as our VFP extension cable, which is basically just a simple Cat5 connector here. Right here on the left, I've got it sitting here so I can easily access it. And I've got the manual override switch. I've actually got the VFP mounted underneath now. Here's manual override, it's set to automatic. So what we're going to do is we're going to go into setup and type in the password there. Okay, default setting. I'm going to main spindle. Then tap that. It'll bring up our settings. What you're going to want to enter in is the coder, pulses per revolution, so 100. On the spindle control method, this is going to be a VFD control spindle. You're going to set the maximum RPM, so when the controller outputs 10 volts, maximum voltage, across the PWM line, control cable, it's going to run at 24,000 RPMs. We're going to give it a 6-second spin up and 6-second spin down. It's specified in milliseconds, so we're going to put 6,000. So it's going to take 6 seconds for the VFD to ramp up. That is directly related to P11 is the acceleration. So spin up is an acceleration for 6 seconds. That matches that. And then P12 is the deceleration. So that's what it's going to match that. Now, what we're going to do is, once you've got that programmed in, you just hit save, go back to programming and MDI, and over here you should see spindle stop. Now our goal is when you hit this button here, the VFD should switch from blinking to solid. That means it is now in forward mode. You can tell that by the FWD, that LED right here. So that's when you hit the spindle CW. CCW is counterclockwise, and that only applies to metal spindles. It's not something the woodworking spindle can really do, because you need low RPMs to go down into threads. But if you hit stop, it should go to blinking. Hit CW, should see it go to solid. If you click MDI, you can actually get to the media controls, the G-code controls. You can type them in here. So since it's already running, M3 is basically the run or run forward command. So we're going to put M3 S6000. So S means going to speed, 6000 is the RPMs. So now it is, slow that down. I forgot I had I've got the IoT power strip in there, which turns on my shop vac. But set it to 5,000 RPMs, M3 S5000, and you should see roughly 5,000, give or take about 5% or so, depending on the quality of the power coming along the line and what voltage is being lost on the power line. It's very technical. Needless to say, you're going to get roughly 5,000. You can change it to like S5200, for example, run, and it'll jump up a little bit. S4000, we should go down. This is basically what your G code will have embedded into it. So if you've got your CAD software outputting the spindle commands, these are the commands that you will find in that G code text file. And then you can hit exit and spindle stop, and it will stop your spindle. And that's it. If you hit spindle forward again, it'll resume the last RPMs that it was set at. So that's it. You've got your machine fully controlled. Or your spindle fully controlled. Okay, let's see. I want to thank you guys for joining. I really appreciate it. It does help us out. Certainly encouraging. So, all right, let's see. So we've got our machine hooked up. We've got our spindle installed. I've got all the footage there. Let me get a slightly different angle and repeat. That's what you have to do when you're making videos. Try to get something else. Just in case you have to go first. Okay, so once you've got everything plugged in, we've got our controller here on the left side. On our VFD keypad extended with a Cat5 cable. We're going to basically go into setup, go to main spindle, double tap that. You're going to set 100 on the encoder, VFD as your control method, 24,000 RPMs. That's whenever it's running at the maximum. So the maximum is 10 volts across the PWM line. We want it to go 24,000 RPMs, which is the maximum on our motor. The spin up and spin down. Spin up relates to P0.0.11, 6 seconds, 6 seconds. Spin down relates to P0012, hit enter, 6 seconds, 6 seconds. And then hit mode to get back out of there. And just hit save. And the way you test it is you go back to program, and you notice that this is blinking 00. When you hit spindle forward, it should go to solid. Now it is currently set at RPMs, which I previously set in the video, or in another video, but we can go into MDI control, and you'll notice some of the commands that I've used before. If we change that to S5000, it will spin up to roughly 5,000, give or take 5 or 10%. I forget the exact number, but it relates to the voltage coming across the line and this sort of thing. Needless to say, it's about 5,000, which is more than enough for any cards, which is like that. About 110 RPM doesn't really make that much of a difference. So we've got the S6000 or 5,000, S3000, or actually that's S300. But you can see how entering these commands, these G-code commands directly into the MIDI window will allow you to control the speed. And of course it stops. Hit exit, and you'll notice that when we hit spindle stop, it should go back to blinking. This basically means your spindle is now fully controlled by your Masso controller. The M3 command triggers the forward, which is a forward function, is the LED right here. M5 triggers the stop and puts it back into stop mode. Okay. Now, we need to do a carve. I need a carving. All right. So the last thing on my video is I need yes. Okay. Okay, if you guys are ever having any trouble with your automatic controls, I don't want you dead in the water. So what we're going to do is I'm going to demonstrate how to use it in manual override. So there's a switch on the side of the vehicle. Flip that up, and that puts it in manual override mode. And basically, it needs all of the controls to run your spindle right here on this keypad. Run. Forward mode, turns dial, and it runs the RPMs, stop, and it stops. Still set. So that's how you run it in manual override. This is exactly the way you run it. Run a COM router, use the power on, just run, set the dial where you want the RPMs to go, run your car, hit stop, and you're all done. Here's how I've got my IoT relay. This is an add-on that you can add to your kit. We offer these digital loggers, power strips, simple IoT. They have a couple of normally off, and always on, and then normally on. It goes off when triggered. These normally off, it's turn on when triggered, which is exactly where I'm going to put my shop vac. This is a Turbo 1. It's really nice, very quiet. Highly recommended. But we've got the power coming in from our circuit. We've got it plugged into the power strip. We've got the shop vac plugged in normally off, and we have our plug plugged right into the side using a simple 2-conductor wire heading over to the VFD I showed you earlier. When the it's in the right angle here. Okay. Keep close eye on the power strip. Whenever the motor goes all above 5,500 RPMs, the shop vac will kick on. So again, you can tell that based on the green light that popped on. And then when it goes below 5500, it turns off. Okay. Carbon. Let's get the carbon. I've got carving, very simple carving on here. Let me pull it up and make sure it actually works before I try to record it. This is USB on the side. Plug it in. We're going to go to load file. Load test file. It's just a simple circle. It shouldn't be too terribly difficult. Just go to debugging. Let's go down a bit. We will set our Z right here. I would do for testing or use a probe or something like that if I wanted to. Right now I'm just going to set the zeros. This is going to be 0, 0, 0. And we can run our program. So let's test our program here. Program. There's our studio there. Got it going up to 15,000. And let us run. Excellent. Okay. So, let's get this recording. Alright, so I've got my system set up. I'm going to put in my bit. I'm going to zero it out, which I've already zeroed it out. I'm going to put this is the removable brush track with a spacer. You can use it with, without if you need that extra ½ inch. Pop that on. Get your bit under there. Got my truck back already hooked up and set up the IoT relay. I've got a very simple test card here. It'll do a couple of circles and that's it. We're just going to carve some air. So I've set the Z height pretty high so that when it goes down, I just carve air and comes back just to show you the whole cycle. We can see what it's doing here on the VFD screen as we're running our program. So we're going to go over to program. We're going to hit green button. Load. Spins up to 15,000 RPMs, triggers the VFD, the IoT power strip, which turns on our shop vac runs through the card. When it is done, here's just a second. Comes over, returns to stop, stops the VFD, stops the shop vac, and the card is done. I want to thank you guys for joining me. I hope you found that informative. Super easy to install, super easy to run. Makes your job a lot easier. The whole thing is a lot more is pleasurable from start to finish. Right? You set up your car. You can focus on setting up your stock, getting it ready, clamping it down. Don't have to worry about the spindle, starting, stopping. Don't have to think about any of that. All that's programmed into your G-code file. Starts up super quiet. This is the air-cooled spindle, but as you can tell, the majority of the noise actually came from the shop vac, and that is a Turbo 1 from Fine. We have some adapters. Here's a little connector and a little maglock converter. Allows you to connect it into our V10 dust boot. That's what we've got here, with removable brush track and spacer, just in case you need some additional, suction, that sort of thing. But I hope you found that informative. Let me know if you have any questions or comments. Reach out to us at support@ponecnc.com. You can also leave a comment at the bottom of the video. We are listening to every feedback. We appreciate all of you. And thank you. And remember, don't just own your CNC, dominate it. I don't know, I find it hard to watch myself. Okay, so that takes care of that. Alright, I am going to jump over and record the install video on my Onefinity Machinist, so that can get all out there, and that information up there. If you, just like I mentioned in the video, if you have any questions or comments, leave it down below of this live video. We'll jump into it. Remember, support@ponecnc.com. And remember, if you have any questions or comments or suggestions, reach out to us at that support email, or on our Facebook group, or on YouTube, or on Twitter, or I guess Threads, Instagram. We're here to help. Let us know. We're happy to help you out. And remember, don't just own your CNC, dominate it!